Good evening, everyone. Welcome to the last question of this week. It's on Friday. So, this week really found a roller coaster week. We had some questions which had only for 2 marks, like yesterday's question was only for 2 marks, and the previous to it, we got one for 16 marks, one for 4 marks, and so on. So, this one is for 14 marks. Okay, so let us start doing this one. I hope you have been getting the answers appropriately and correctly, and continue doing this one. So this will really help you out, okay, to do more number of problems appropriately. Right, now let us do with this. So this question is divided into two parts. We are doing only one part, I think. So let me see whether I am doing both the parts. Part 1 only I am doing it here. Part 2 will be much more higher, so which we are not doing it. Okay, so part 1, a nucleus of radium 91 undergoes alpha particle decay to form a nucleus of radon. Identify the proton number and nucleon number of the nucleus of radon. Okay, so what is he asking? Identify the proton number and nucleon number of radon. Okay, many people make a mistake. They just look at this one here and get the answer, which is wrong. So now what we do is, so let us write down. See, radon reaction, radon value is not given here, right? So what I will do is I'll write 91 radium 226 will give rise to an alpha particle. Alpha particle is what? 2He4 plus you get a radon here. Now radon, what will be the value of Z and A here? So 91 and here it is 2. 91 minus 2 should be 89 here. 226 minus 4 should be 222 here. Now what is proton number? There are 89 protons, and nucleon number should be 222 here. Don't do 222 minus 89. Okay, we are not asking neutron number, we are asking nucleon number. So this will give you 2 marks. Blindly, aram se you can get this one here. Let us move on to the next one. Immediately after the decay of a stationary radium nucleus. Okay, so initially you had a big nucleus which was radium. Then the alpha particle in the nucleus, the radon nucleus, moves off in opposite direction at different speeds. Outline the reasons for these observations. So this was 3 marks. Read the question carefully. You say that both the particles move off in opposite direction and different speeds. So you have to give 1 mark here, 1 mark over here. Okay, this is nothing but from the conservation of momentum. So what does it tell you about the conservation of momentum? The first thing is that no external forces act, right? No external forces act on radium, but still there was an explosion or splitting of a nucleus. So this implies conservation of momentum can be applied. Okay, this is the first reason you can say. This gives you 1 mark. Then when you say conservation of momentum can be applied, then you can write m alpha into, let us say this is u and this is v here. M alpha into u plus m radon into v is equal to m radium into 0. Okay, stationary. So as a result of it, what you can do? You can write m alpha. What I will do is I will write this as p alpha and this as p radon is equal to 0, or p alpha is equal to minus p radon, right? Momentum of alpha is equal to minus of momentum of radon, which means the directions are opposite, which implies directions are opposite. Second mark. Third mark, what is the third mark? Third mark, it's ask you about they move at different speeds. Why different speeds? Alpha and radon has different masses. Therefore, from here what do we have? M alpha V alpha is equal to M radon V radon. This implies V radon by V alpha is equal to M alpha by M radon. So, which is not equal to 1. Hence, Vrn is not equal to V alpha, which means they are moving at different speeds, right? So, I have said all the 3 of them. This is the way how you need to write. Okay, so this will give you third mark. Then, show that the ratio initial kinetic energy of alpha particle by initial kinetic energy of the radon atom is about 56. So, initial kinetic energy of alpha particle. So, what is this? This is half m alpha V alpha square divided by radon is nothing but half m radon V radon square. Okay, that's what you need to find. Now we already know from here V radon by V alpha is M alpha by M radon. Let me substitute that. It is half and half goes away. So I have M alpha into V alpha by V radon. V alpha by V radon is nothing but M radon by M alpha. So M radon by M alpha the whole square. Here I have M alpha by M radon. So which should now be equal to, see this whole square, this and this square, this and this square goes away. So I get this as M radon by M alpha, right? Now what is M radon? What is the weight of M radon? Radon particle, what was it? I got 222 nucleus, right? 222 nucleus. This was 222 nucleons, and alpha particle has 4 nucleons. When I do this, how much will get? 11 by 2, which is nearly 55.5, closer to 56, right? Thus we have proved it. Okay, so I'll continue the rest of the problems in the next video.